This lesson explores how to execute code based on a condition using a case structure. Conditional logic allows you to execute code based on a condition. That is, if a particular condition is true, then do some action, else do some other action. For example, if the acquired temperature is greater than or equal to 100 degrees Celsius, then display a warning dialog box and a message that the temperature has exceeded the maximum limit. Otherwise, display an indicator that the temperature is in normal range. Let's take a look at a VI that implements this conditional logic. First, I'll run this VI. Notice that if the temperature is greater than or equal to 100, the VI produces a warning dialog box and this message. Now notice if I run this VI and the temperature is less than 100. I get a different message and no warning dialog. Let's take a look at the code on the diagram. Notice that it contains something new called a case structure. We'll take a look at that next. When using a case structure, the first thing you should do is wire a condition to the case selector input. The value that the VI passes to the case selector input determines which case to execute. The case selector label allows you to navigate through all defined cases. You can place your code in the corresponding case. In this example, the greater than function passes a true or false value to the selector input of the case structure. If the selector input receives a true value, then the case structure executes the code in the true case. If the selector input receives a false value, then the case structure executes the code in the false case. A case structure adapts its cases based on the data type wired to its selector input. For example, if you wire a Boolean to the selector input, the case structure contains a true case and a false case. If you wire an integer to the selector input, the cases can be a single number, multiple numbers, a range of numbers, or a default case. If you wire a string to the selector input, the cases will be strings. If you wire an enum to the selector input, the cases will consist of the enum values. If you wire an error wire to the selector input, by default, you get a no error case and an error case. You can have multiple error frames to handle ranges of error code values. A case structure can also include tunnels. An input tunnel is available to all cases if needed. If you have an output tunnel, you must define a value for every single case the tunnel outputs. The output tunnel is a solid color if you have wired a value to the output tunnel in every case. The output tunnel is white with a thin border if there are one or more cases where the output tunnel is unwired. You also have the option to configure an output tunnel to automatically use the default value of its data type if it's unwired. In that situation, the tunnel is white with a thick border. In this example, the bottom tunnel is a numeric data type, so the default value is 0. To create a case structure, you need to go to this palette and select it. Then drag to place. Once the case structure is down, you need to wire the case selector terminal to a condition. In this case, our condition is a Boolean. Now, let's define what happens in the true case. For the true case, let's go ahead and put a one-button dialog function down. So, if the condition is true, we'll display the following message. And now let's define the code for the false case. Let's go to the false case by going to the selector and choosing the false case. I'm going to put down another one-button dialog. So if the condition is false, the application is going to execute this case and display this dialog. Now, let's go ahead and test this VI. Let's turn on Highlight Execution so we can see what happens. Here in the front panel, I'm going to select On, which is the true condition, and run the VI. Notice that a true value was passed, and it executed our code in the true case. Now let's try with the false condition. I'm going to switch this off. Let's run the VI and notice that the false value gets passed, and we also get the code executing in the false case. Now let's use a case structure to execute a code based on a numeric condition. The first thing we want to do again is wire our selector to the condition. In this case, it's numeric. Notice that the case selector label has adapted from true and false to something numeric. For now, we have a 0 and a 1, and we also have a default case. The default case executes any numeric that is not defined by any of the other cases. Right now, if the numeric passed in is 3, we would actually go and execute the default case. For numerics, we have more than just 0 and 1. We can have the numbers 5, 10, 15, -20. If you want to add more cases to a case structure, one way to do that is right-click the case structure and select Add Case Before or Add Case After. So for this one, I could say that I want this case to be 5, but I could also say I want this case to execute whether it's 5, 10, or 15. Notice now we have a case for 0, we have a case for 1, and we also have a case for 5, 10, and 15. 5, 10, and 15 execute the same case, and we still have our default case to capture all other integers. Let's go ahead and add another case. Say you want to add a random number, everything from -1 to -infinity. So for the name of the case, I'll put this in. And now any number that is -1 or lower is going to execute this case. If I want to add another case for random numbers from 50 to 100, I can type 50 ... 100, and that will be a range. If I want to add another case for everything from 101 and greater, I can do this. Notice now there are single numbers, a default case to capture everything that is not defined here, and we have multiple numbers and ranges as well. Now let's talk about how to use case structures with an enum condition, and then we'll talk about how tunnels work. In this example, our enum has items of add, subtract, multiply, and x to the second. Let's go ahead and wire the enum condition to the selector terminal as usual. Notice that the case selector label has adapted to the enum items, and now we have add and subtract here. Notice that we have more items in the enum than we have in the case structure. To add those, you can right-click the case structure and choose Add Case for Every Value. This is something special for enums. Now notice that we have a case for every single enum value. We have add, subtract, multiply, and x to the second. Now let's explore how tunnels work. Let me go to the add case. What I want to do is put an add function here and create some tunnels. Notice that these are input tunnels. We have an input x and y. And now let's create the output tunnel. We're going to take those and we're going to send our output here. Notice that the output tunnel looks empty. Remember, the reason for that is that this tunnel has not been defined in every case. If you look at the subtract case, for example, notice that we don't know what the output to this tunnel will be. So the output tunnel needs to have a value defined for every case. In the meantime, I'm going to fill this out. This is the last case that does not have anything wired to the output tunnel. Notice that as soon as I wire something to the output tunnel in every case, the tunnel now appears filled. Notice that it's okay if the input tunnel isn't used in every case. So for example, in the x to the second case, the y is not used, and that's okay. If it's okay for you to use the default value for any output tunnel that doesn't have a value, then you can right-click the tunnel and select Use Default if unwired. If you want to execute code based on user input, you can wire a control terminal to a case structure. In this example, if the user sets the triggering enabled control to true, then the VI will execute the DACMX triggering VI to set up this task and wait for a trigger. If the user sets the triggering control to false, then the VI will not execute the DACMX triggering VI, so the task will not wait for a trigger. You can also execute code conditionally based on a measurement result. In this figure, the example VI reads a waveform, extracts the maximum value, and checks if that maximum value is greater than a threshold. This result is wired to the selector input of the case structure. Now, if a waveform maximum is greater than the threshold, the case structure will display the waveform in the last exceeded acceleration graph. Otherwise, the case structure will do nothing because the false case is empty. Here's a summary of what you've learned in this lesson.